All right. So 2 days ago, you guys learned how to simplify rational expressions into something more simple and compact, and you were able to look for restrictions. This is the spot in your math careers where you guys learn how to multiply and divide rational expressions together. So it's essentially we're taking the skills from earlier, like grade school courses of multiplying and dividing fractions, but now we're going to be multiplying and dividing those expressions you worked with 2 days ago. So just to kick things off, I've got a refresher on how to multiply fractions. You guys have a fraction button on your calculator now, at least like display calculators do. So you've maybe for the last few years of your math career, you've been relying on that button. But everybody has learned how to multiply fractions. When you multiply two fractions, you multiply the tops and you multiply the bottoms. So 2/3 times 1/7 is equal to 2/21, I think. That should sound familiar, ideally, for the three people. You guys have also been dividing fractions your whole math careers. When you divide two fractions, you were taught to invert the second one and multiply. So you change 9/8 divided by 3/2 into 9/8 times 2/3, and then you use the rule above. Multiply the tops together, 18, the bottoms together, 24. And of course, 18 over 24 reduces to 3 over 4. So because we're going to need these skills today, without using your calculator, please, can you guys multiply or divide? I think I want to make the last one dividing, actually. If you've already gotten there, apologies. You can just do an extra one onto the side. We're gonna make that one a division. All of these skills with multiplying, dividing fractions, we're going to be using today. I'm even going to show like an extra step for this first one, although I don't think you guys need it. Multiply the tops, 1 times 1. Multiply the bottoms, 2 times 3. A half times a third is a sixth. I got that one for you guys. I'll even show an extra step for this one. Multiply the tops, 3 times 7. Multiply the bottoms, 4 times 5. You guys get 21 over 20? Of course you did. Now, for C, I'm actually going to show you guys how you can do C two ways. So there's two options that you could do. The first way, you could just do what we just did. 4 times 9 is 36. 5 times 2 is 10. 36 over 10 is perfectly correct. However, that's not reduced to lowest terms. That could be simplified to 18 over 5. It is possible, and I'm just going to recopy down below 4/5 times 9 over 2. Maybe in an earlier grade, you were shown that when you're multiplying fractions, if you have, let's say, a 4 on top and a 2 on the bottom, like 4 divided by 2 is exactly 2. So maybe you saw this in earlier grades where you can be like, well, I know that 4 divided by 2 is just equal to 2. It's like 2 over 1. And now I can just do 18, 2 times 9 equals 18, and 5 times 1 equals 5. And I get 18 over 5 directly. Not one of these is not better than the other. You can do whatever you want. I'm not your dad. But I will actually be making use of both of these methods later. All right, can you guys carry on and do those divisions? I'll catch up in a second. If you haven't tried those already. All right, here I come for D. So we're dividing by 1 over 3, which means we would multiply by 3 over 1. And I'm just going to go right to 3 over 2. Of course, if you were in the wild and you had to do that division, using a calculator is no problem. Here, we're showing our steps because we have to apply these skills later. We want to make sure that we're there, we have them down. E, we would change this to 6 over 5 times 5 over 2. So method 1, you would do 30 over 10. 30 over 10 is equal to 3. Nothing wrong with that. Maybe, just maybe though, in an alternate universe, you saw that, hey, 5 over 5, that's 1. 6 divided by 2 is 3, and you went right here. That's totally fine too. And then finally, let's wrap this up and move on to the good stuff. So this is 8 over 15 times 2 over 9. Which gives us 16 over 135. I don't think that can be reduced. All right. We've brushed up on our multiplying, dividing fractions. Anything you guys want to chat about before we ramp things up? Okay. Now, before we get to doing the stuff we're doing today, and you're like, why am I going to use this? Well, there's a lot of applications in real life. I've got 2 from physics here, but not just from physics, where relationships between things involve rational expressions. In your grade 12 functions course, if you choose to take that one, you do a whole unit on rational functions where you sketch and you solve equations. And the skills we're learning today will help you with that. You guys can correct me if I'm wrong. It's grade 10 science. Do you guys do like convex, concave, and the mirror diagrams and stuff? Did you guys get to use this equation in your grade 10? I don't know. Past experience, nobody in grade 10 likes using that, but they're rational expressions. From my understanding, the people that took physics last semester, you didn't quite get to simplifying circuits, where when you're looking at resistances, rational expressions are involved. I digress, but I'm just saying there's many applications of rational expressions. So let's continue. Now, can you guys, I believe for you guys, this text is on the next page. Is that true? Did I fix it for you guys? Did I fix that for you guys? Okay, nobody talked to me. We'll just continue. That's fine. It's fine. All right, so we are going to do our first example. We're going to multiply some rational expressions together, and we're going to be making use of our exponent rules from earlier grades. I'm going to show you 2 methods we can use to simplify this expression, to multiply these 2 rational expressions together. So here we go. The first method is to just go at it like you would multiplying 2 fractions. Just multiply the tops and multiply the bottoms. So 4 times 12 is 48. X squared times x cubed. You would add the exponents. That's x to the power of 5. And then on the bottom, 3 times 2 is 6. X times x is x squared. So we're just using our skills from our grade 9 math course there. And now we can divide those 2 rational expressions together. You guys learn how to divide monomials in your grade 9 math course. You divide the numbers. 48 divided by 6 is 8. And then dividing the variables using your quotient rule for powers, you would subtract the exponents, and you get 8x cubed. So this big mess, at the end of the day, is equal to 8x cubed. Almost. Think back to 2 days ago. There'd be one value of x that actually makes that expression undefined. You guys see what it is? What would Forrest? 0. If you plug 0 into here, you get 0. If you plug 0 into here, you get 0 over 0 times 0 over 0, which is weird, and it's not defined. These two things are almost equivalent. We have to add in, just like last day, we have to add in x can't be 0. Anything that makes a bottom 0, we got to put in as a restriction. All right. Now, method 2, I'm just presenting an alternate method you could use. Take it or leave it. You could simplify a little bit first. So what do I mean by that? For example here, if you saw that, let's say, 12 divided by 2 was equal to 6, then you could do that first. And then maybe you saw that, hey, x squared divided by x, well, I can just divide out a factor of x, like so. You can reduce things a little bit, make things simpler, and then multiply. So what we would have left would be 4x over 3 times 6x cubed over x. And we should get the exact same answer. So multiply the tops, 24x to the power 4, multiply the bottoms, 3 times x. Now divide those two monomials. 24 over 3 is 8. X to the power 4 divided by x to the power of 1, x cubed. And x can't be equal to 0 again. Everything's in there. I'm going to give you guys personal preference. In a situation like this, I find simplifying first is too clunky. I don't like doing it myself. I would rather just multiply and then do the simplifying afterwards. But I'm not your dad. You do what you want. I've given you two options. My preference, I think, is cleaner, is to multiply first, then simplify. All right. Our first example, multiplying some rational expressions together. Let's continue. Let's divide some rational expressions together. And I'm going to use method 1 here. So we're going to find an equivalent expression for the division of these two rational expressions. But we're just using our dividing fraction skill. We're using our multiplying monomial skill and our dividing monomial skill. It's all skills from earlier grades. You guys can do it. So you would rewrite as a multiplication 100ab squared over 4a multiplied by, and then you flip, 12b squared over 15a squared. Now, if you can see 12 over 4 is 3, or 115 can both be divided by 5, you can simplify. For me, it just doesn't do it for me. But now I just multiply the tops together. 1200, we have a and then b to the power of 4. And on the bottom, we have 60 a to the power of 3. And now we can divide those two monomials together. So what are we left with? Well, 1200 divided by 60 is exactly 20, I think. I think it's exactly 20. And then if we look at the b's, there's just b to the power of 4. We're not dividing by anything, so we'll have b to the power of 4. If you're wondering why I did the b's first. If you guys use the quotient rule for a to the power of 1 divided by a to the power of 3, you get minus 2, right? A to the power of minus 2, which is fine. But we usually like writing things with positive powers. So my personal preference is, if I can see that there's 3 factors of a in the bottom and 1 factor of a on the top, then I'll just simplify that as 2 factors of a on the bottom, right? Divided a factor of a. I have so much space. Why does that work? Because a over a times a times a. Well, if you just divide out two factors of a's, you're just left with 1 over a squared. So we would write that as 20b to the power 4 divided by a squared. Those two expressions are equivalent, Washer, almost. Can you guys walk back through the question? Are there any values of a or b that will make the bottom 0? Does any of you three people see any restrictions? You see one, Sam?
0.
What can't be 0? A can't be 0. You are correct. There is one more restriction here. If you guys dig back all the way through the problem, there is another point where a value of a or b, strong hint, would result in us dividing by 0. You see where it is? What do you think, Forrest? If b is equal to 0, we'd have 15a squared divided by 0. Dividing by 0 is bad. We can't do it. Anywhere you guys see some value of a variable that makes the bottom 0, it's a restriction. We also have a restriction here. B can't be equal to 0. You guys put this question on your note 2 days ago. You're going to put it on now. What makes the bottom 0? And I'm going to include in brackets here, anywhere. Anything, anywhere that makes, that's like a movie title, I think. Everywhere that makes the bottom 0. That'll give you a restriction. All right, so we've multiplied some rational expressions. We've divided some rational expressions. These were all just monomials, though. Let's ramp things up. All right, now I will admittedly say an expression like this, when you're doing physics, you're doing engineering, whatever, you're not going to find expressions like this out in the wild. The purpose of doing problems like this is to build up your skill set and make your algebra skills stronger. That's why we're doing it. Now, this question here, we're not quite ready to do any multiplications and simplifying because we have some expressions here that can be factored. So in these new questions, you guys are going to look for situations where you can factor. This unit is called Factoring Applications. This is our second, really, application. So you guys should have a mindset where if you can factor, you factor. So let's start this one off by factoring anything we can. So I recognize that a squared plus 2a has a common factor of a. So I will common factor it out. That is grade 10 level factoring. You guys did lots of common factoring last year. We also did that in the warm-up. We took out a factor of x. 3a on the bottom, nothing I can do with that. Times 20a squared, can't factor that, it's just a monomial. But 5a squared plus 10a, we can common factor. 5 and 10 have a common factor of 5, and also each term has a factor of a. My printing is really nice right now. What are we left with? A plus 2 when we divide it out. All right, but now that we've factored, we can see a lot of common factors on the top and the bottom. Here's where that second method of multiplying fractions comes in. I don't want to have to multiply this stuff together and this stuff together if I don't have to do all of it. Look, would you guys agree we've got an a plus 2 on the bottom and an a plus 2 on the top? Why don't we just cancel those out? That just means we won't have to multiply them. It makes our lives a lot easier. So I'm going to divide out those two common factors. And now, personal choice. If you want to keep dividing out a's and dividing 20 by 5 and everything you can, go for it. For me, it just makes things a little bit clunky. At this point, what we're left with is we have a divided by 3a, and we have 20a squared divided by 5a. And now it's just like that first example we did. Can you guys multiply the tops, multiply the bottoms? We'll simplify, and then we'll see if there's any restrictions. "3M people, I'm going to do one more example here, and then I'm going to let people do a bit on their own, and I'll come tour around. All right, here I come. So a times 20a squared, 20a cubed. 3a times 5a is 15a squared. And what you're left with, 20 divided by 15. So if you're using a calculator, you're going to get 1.3 repeated. We generally don't prefer to write down decimals that don't terminate like that. I'm going to leave it as 4 over 3. And a cubed divided by a squared is just equal to a. So we that whole big mess at the start of the problem simplifies down to 4a divided by 3. That's crazy. Almost. There are some restrictions. And maybe we can get some people that haven't helped out yet today. Can you give me a restriction on a? Something, a problem value for a we can't plug in. I'm going to make the bottom 0. Okay, Madeline, you go. 0 is 1. Can you guys scan through the problem? Is there any other situation where some specific value of a will result in us dividing by 0? Go all the way up through the problem. There's one more restriction on a. You got it again? It is -2. Excellent. Also, that's a weird comma. Also, a can't be equal to -2. I kind of list them one at a time. See here, if a was equal to -2 right here, you'd be dividing by 0. That's bad. So you guys should be in the habit, walk through every step. If dividing by 0, it has to be a restriction. All right, let's ramp things up one more time. Can you imagine telling grade 10U you'd be doing this in the first month of 3U? We're going to divide these two rational expressions together. Now, it looks a little intimidating right off the hop, but let's see if we can do some factoring and have a whole bunch of things just divide out so that we don't have to work with them. So you've got 1, 2, 3 quadratic expressions that we need to factor. And I think I said this a couple days ago. I can't apologize. We just have to be able to factor at this point in our math careers. You did learn factoring last year. So step 1, factor anything you can. Anything you can get your hands on, you want to factor it. So top left, we can divide out a 2, we can divide out an x. Did that one in the warm-up. That's just master teaching right there, tying it all together. X squared minus 3x minus 10. We have reviewed simple trinomial factoring. What adds to minus 3 multiplies to minus 10. I'm just going to go right to the answer. We can't really spend 2 minutes on every simple trinomial anymore. We just got to keep blasting through. Divided by, we got 4x squared. And then x squared minus 9x plus 20. What adds to minus 9 multiplies to positive 20, minus 4, and minus 5. All right, guys, don't be too hasty, just slash and everything and crossing stuff out. We need to have this written as a multiplication before we do that. Let's rewrite this as a multiplication. So we invert and multiply. X plus 2 times x minus 4, x minus 5, all over 4x squared. All right, and now you can wipe some things off the map if you can. I can see here we've got x minus 5 on the bottom, and we have an x minus 5 on the top. And because we're multiplying, I can just cross those out. Do you want to do more? If you can see 2 over 4 makes 1/2, you could simplify that right now. If you have x over x squared, you can simplify that right now. Me, I don't prefer to do that. I'm just going to rewrite what I have. Over x plus 2 times x minus 4 over 4x squared. Now I'm going to multiply these two things together. So on top, we have 2x, and we're multiplying x minus 4 times x minus 4. It might be tempting for some of you guys to try to expand that out. Expanding is actually kind of counterproductive here. We'll just write that as x minus 4 squared. And on the bottom, we'll have 4x squared times x plus 2. We can do the tiniest bit of simplifying because 2 over 4, this is where I'll do that. 2 over 4 is equal to 1 over 2. So I'll cross that out using deep purple. And then x divided by x squared, that's going to leave an x on the bottom. And so what are we left with? Phew. We're left with x minus 4 squared on top. We're left with a factor of 2 on the bottom. We have a factor of x on the bottom and x plus 2. So that big mess on the top has now become this slightly less bigger mess on the bottom. And they are equivalent, almost. There are some restrictions on x. I will tell you guys, there are 4 of them. Can you guys find the 4 values of x that make a bottom 0 anywhere in that problem? Anywhere. There is 4. All right, there's 4. So maybe we can get 4 different people that haven't helped out yet. Maybe we can start with the lay-ins, and then Nina, you got one? X can't equal 0. That's one from the very last line. Fantastic. I'm going to list them as a set of numbers here. Somebody else give me another one. Jaden. Can't equal 5. And that came from these lines here, right? Yeah, exactly. So 5 is another restriction. Good. Somebody else give me another one. Colin, you got one more?
-2.
-2 from the last line. Great. And Kaden, you haven't helped out yet? 4. Perfect. 4 from an earlier line somewhere. Yeah, very good. The very first step where we factored, it's on the bottom here. Great, you guys got them all. So I listed them all as a list of numbers. If you want to just write them individually, x can't be 0, x can't be 5, x can't be -2, and so on and so forth, you can. All right, we've done well. I think me doing more at you is a bit counterproductive here. Can you guys, at the very least, start trying these following ones? Factor everything you can first. Rewrite as a multiplication if it's not, and then you can start slashing and canceling. So give them a try. These ones I will be taking up with you guys in class. I have an additional sheet of extra practice, and at this point, I'm going to go check in with the 3M people, and I'll pause my recording. So 3U people, I'm going to go over the first two. If you guys would rather just keep practicing, just practice quietly, okay? Because I think some people want to see me take these up. All right, so again, 3U people, Forrest, Andrew, 3U people, either I'm going to go over the first two so you can follow along, or work quietly just so people can dial in and focus. So step one, we factor as much as we can. And we can factor the top left and top right here. We have a difference of squares. So hopefully after our review periods, those things are fairly automatic. Next, look for things to cancel, x plus 1 and x plus 1. We have x minus 4 and x minus 4. And so this one simplifies down quite a bit. You're left with x plus 2 times x plus 4. If you expanded that, that's not wrong. At this point in the course, it's actually beneficial for us to leave it factored. Of course, you guys should be used to looking for restrictions. What makes the bottom 0? In this case, 4 and negative 1. Okay, you guys get that too? That one was I'd say that one was a pretty tame one. In B, we have to do a bit of factoring. Let's just dive in. X squared minus 9, difference of squares. I'm going to be moving through these a bit faster since we've reviewed these and you did these in grade 10. Bottom, difference of squares. I'll keep it division. So top right, perfect square trinomial. Bottom right, perfect square trinomial. You could also factor those as simple trinomials. Can't do any canceling yet. You have to have it as a multiplication. X minus 3 over x plus 2, x minus 2 times x plus 2 squared over x plus 3 squared. Now is where we can do our canceling, if we can. So take note, we have 2 factors of x plus 2 on the top, 1 factor on the bottom. I can't cancel both, I can just cancel 1. And it's the same with the x plus 3s. There's 1 of them on top, and there's 2 of them on the bottom. I can only cancel 1. And so we're left with x minus 3 times x plus 2 over x minus 2 times x plus 3. That's the best we can do. Of course, you guys are getting in the habit now of stating restrictions. I think I'll list them just as a list here. So everywhere through the question, what makes the bottom 0? Every single line, there are 3. There's 2 and minus 2 from the bottom left, and there's minus 3 from the bottom right. Everything else is okay. Move my face here. All right, so there's 2 more in the books. I'm going to get some extra practice distributed around while you guys try the last 2. As I do that, I'm going to give the same spiel again. When you guys are practicing at home, and I think many of you guys, 3U people, this particularly is a lesson you're probably going to want to practice this more to make sure you have down. I'm going to give you lots of opportunity with some extra practice. It takes practice. I don't think you can do 2 or 3 of them and have the content mastered. But when you're at home or on lunch or whatever, and you're kind of stuck, bring out Photomath, bring out ChatGPT. They can do these questions no problem, and they show a ton of steps. That's not cheating, that's smart when you're practicing to get help getting unstuck. So I'll take up the last 2 in a few minutes, and then pass around some extra practice for you guys. That's not what I did at all.
Oh, I didn't see it either.
I just took it up, right? You have to factor. So it's different squares.
Oh yeah, it's
All right, I'm going to walk through C with the 3U people. So factor what you can. There's only one in the top left to factor here. The strategy we have reviewed already, everything that can be divided by 2 here, we can common factor it out. And you have a simple trinomial left over, adds to -1, multiplies to -6, -3 plus 2. And then we see, hey, those x plus 2's divide out, life is good. We then multiply what we can. 2 times 8x cubed is 16x cubed. And then finally, we divide what we can. We got 16x cubed divided by 4x squared. Using our grade 9 skills, 16 divided by 4 is 4. Our power law is x cubed divided by x squared is just x to the power of 1. And the 2 things to make the bottom 0, 0 and -2. I think for the people watching this, I'm going to stop the recording, but I will post a filled-in note with the last example done before I leave the room.